Let's talk about very important difference between two different differential equations. Sometimes students like miss this point. So for example, if you look at these two differential equations, so yeah, the first one is dy over dx equal x squared plus 1, and here you notice that the x is the independent variable, and the second one is dy over dx is y squared plus 1. So that means the first one is a function of the independent variable, the second one is a function of the dependent variable. So if you want to solve these two, what are you going to do? Can you integrate both, or only one of them can you integrate? So that's the question we're going to answer this one, and you will be you can see what's going on, and then you will see that only one of them directly integrate, the other one you have to do something before you integrate. So let's look at the first one. The first one is the easy one. So we have dy over dx equal x squared plus 1. I'm going to call this equation number 1. So what you can do, since the right hand side is the function of the independent variable, what you can do is you can directly integrate this one. So integrating with respect to x in this case, so integrating with respect to x. So what's going to happen? So you integrate this side, so it's a dy over dx times dx equal, on the other side you have x squared plus 1 dx, and you can see left side, so you have a function y. You first take the derivative and then integrate, so that means you get the function back. So in this side clearly you get the function back y, and for the other side you can just use the power rule, and you can write this one as x cubed over 3 plus x means you start with 1 means you start with x, and then you also have the constant. So that means this is the answer. So this one is easy. So you integrate and you get the answer. Now let's look at the second one. So what we have as the second one, so we have dy over dx equal y squared plus 1. So here the problem is this side is a function of, so the function of the dependent variable, the dependent variable y. So because of that you cannot integrate this one directly like this. If you try to integrate, with respect to x, and then you in trouble, because you can see it's a function of y, not a function of x. So that means you cannot directly integrate. So you notice that cannot integrate with respect to x. So integrate cannot integrate with respect to x, because x is the independent variable, it's a function of y, so you cannot do that. So instead what you can do, you make some arrangements here. So we have a problem here. So you make some arrangement. What you're going to do, you're going to move this y term to the y side. So that means you can write this one as dy over y squared plus 1. So you move it to the y side, and dx you move to the other side, so you can write this one as dx, 1 time dx. So now, so this is a differential. I mean, those differential related by these two relations. So it's like it's according to Riemann sum, you just integrate this one. When you add them, that means a Riemann sum. So you integrate. That means if you integrate, so what will happen? So you integrate two sides separately. So we can do that. So that's what we do in this case. You cannot just directly integrate, but you're going to move the terms to the other side, so that y stays with one side, x stays with the other side. This also sometimes we call the separation of variable method. But here, like, you can just remember this as like a basic technique. So if you integrate, and you know that 1 over x squared plus 1, or 1 over y squared plus, in this case, it doesn't matter whether x or y, it's just a variable. So you know this result, dx over 1 plus x squared. So this is the derivative of the arctan or tan inverse. So that means this is simply going to be tan inverse x as a formula plus c. So in this case, we just have a different variable. So that means if you integrate this one, you're going to get tan inverse y in this case. So tan inverse y equal on the other side x plus c. So that's what you get. And if you take tan of both sides, you can write this one as y equal tan x plus c. So you can see that this answer is completely different from the previous answer. Because last time you get y equal x cube over 3 plus x plus c, but this is completely different. So this is a really good point that you need to remember, and it's going to help you in many cases, and you can avoid issues. And also I'm going to show you like another way to look at this one quickly. So so let's do this. So let's look at the same problem. So we have dy over dx equal a y squared plus 1. So what we're going to do, you're going to integrate. First actually bring the terms as before. So we can write this as 1 over 1 plus y squared dy over dx equal 1. Now what we're going to do, you think backward. You think backward and think about if you had used the chain rule, why you get this one? From what function you get this one? Just like another way to see this one. What from what function? So you think backward and think about the chain rule. And when you do the chain rule, and you know that you first take the derivative with respect to y and then multiply by dy by dx. So you think about what function you had started with. So that's the second argument. So by the chain rule, the left hand side is the derivative of the tan inverse x function. So you can see it's a tan inverse y function, tan inverse y function. So if you have tan inverse y, if you take the derivative, this is exactly what happens. You get 1 over 1 plus y squared dy by dx. So that means if you go backward, you can write this one as simply because this is the derivative of tan inverse y function. And on the other side, and you're gonna have x, means if you go backward, there should have been x there and maybe a plus c. So that means this is how you get the answer using a different like chain rule type of argument. So try to remember this argument, because this will be very useful when you can take the integral directly or when you cannot take the integral directly. So this is like gonna help you a lot. Okay, thank you for watching.